All right, Algebra 1, welcome back. These are your 2-1D notes, and today we're going to be multiplying binomials. And basically, in the 2-1C notes, we took a monomial like this, negative 2k squared, and we distributed that through a polynomial. So basically what we're going to be doing today is just extending that topic, and we're going to be multiplying a binomial, which means two terms, through another binomial, so another set of two terms. So let's just recap what we did yesterday. So I have this one done here for us, so I'll walk you through it. We're going to take this negative 2k squared, and we're going to multiply that through this entire set of parentheses. So remember, multiply the numbers out front. If there is no number, remember it always means that there is a 1, it's just not written. Same thing for the exponents. If there is no number there, that means there's a 1, not a 0. So we multiply the numbers out front, and then we add the exponents. Negative 2 times 1 is negative 2. 2 plus 3 gives us k to the fifth. Next, don't forget the negatives out front. Negative 2 times negative 4 is a positive 8. And then add your exponents for k, so 2 plus 2 gives you k to the fourth. Last one, negative 2 times a positive 8 is a negative 16. K, add the powers, 2 plus 1 gives you k to the third. Okay, so there's another example for what we did yesterday. And like I said, what we're doing today and in the next notes, we're just building on this topic. So often what people use to do this is a binomial, two terms, and this is another binomial, another two terms. People use this method called the FOIL method. Stands for first, outer, inner, last. Okay, F is first, O is outer, I is inner, L is last. So the FOIL method, this is just a method that some people like to use to multiply binomials. Now, me personally, I'm not a huge fan of it because it only works for two terms times two terms. And when we expand this to two terms times three terms, some people try to use the FOIL method, and then what happens is you end up missing some terms, and then it just kind of gets messed up a little bit. But I know some people like to use this for two terms times two terms, and it really helps them to do this. So what this means is the first terms, multiply your first terms, so 2x times 5x, you can see that right here. The outside terms, which would be 2x times negative 8, and you can see that right here. And then your inside terms, so 3 times 5x, you can see that right here. And then the last term, so 3 times negative 8, and you can see that here. So basically this, the way that you see this written over here, this is how we will do it when we multiply these out. And then the one thing we always want to remember is we have like terms here in the middle that are combined together. Negative 16x plus 15x is negative 1x, so that is the last step that we always need to remember is combining our like terms. All right, so let's jump into some examples here. So again, when I'm looking at this, what I do is I take this x and I just look at it as distributive property. So I'm going to say this x needs to be distributed through this second set of parentheses. So I'm going to distribute it. X times x is x squared. Keep going. X times negative 2 is negative 2x. Okay, and now I'm going to take this term here and I'm going to do the distributive property again. So you can see how, like what I was saying with yesterday's notes, we're just building on that concept of the distributive property because that's all we're doing here. We just did the distributive property with x. We multiplied it through. And now we're just going to do the same thing with 3, right? It's just the distributive property. Again, we're just doing the distributive property twice now. So let's distribute the 3 through. So 3 times x is plus 3x. And then the last thing here, 3 times, don't forget the negative 2. 3 times negative 2 is negative 6. Okay, we're not done. Some people say, all right, I'm finished. I just did my distributive property. I'm done. Final answer. No, we're not completely finished because if you remember in section 2.1a, we didn't just cover that section for no reason. We covered it so we knew how to combine like terms. So right here are the like terms, right? So x squared does not have a like term, so x squared. Negative 2x plus 3x is just plus x, and then the negative 6 did not have a like term, so we bring it down. Okay? So we have 4 more examples of this that we're going to go over, okay? But that is the general concept. So if you're someone that picks up on things quickly, what I would suggest you do is pause the video, try the other 4, see if you can do all of them, and then just fast forward through to all the answers and check your final answers on all of them, okay? Because I know some of you can do this really quickly. You pick up on topics quickly, and you're like, oh yeah, I know how to do that, and you can just do them really quickly, all right? But if you need to walk through a couple more examples, let's go ahead to the next one. I have this one done for you, so I'm just going to talk you through it. So first up here, we have 2x times x. So 2x times x is 2x squared. And then we do 2x times 5 is 10x. And then we have 3 times x is 3x, and 3 times 5 is 15. So let me slide this down here now, and I'll say it again. 2x times x is 2x squared, that's my first term. 2x times 5 is 10x, that's my second term. 3 times x is 3x, that's my third term. And 3 times 5 is 15, that's my last term. Again, I have like terms here in the middle, 10x plus 3x. Remember, same variable, same exponent. That's why we can't combine it with this one, because this has an x squared, right? So they don't have the same exponent. Add those two in the middle, 10 plus 3 is 13. Final answer, 2x squared plus 13x plus 15, and I'm finished with example B. All right, let's do C together. 5m times 8m. Remember, we're going to multiply the numbers. 5 times 8 is 40. M times m, add the powers. 1 plus 1 is 2. 5m times negative 1. 5 times negative 1 is negative 5. And then, since the 1 doesn't have an m, we just bring that m down. And now we have 2 times 8 is 16. Same thing, the 2 doesn't have an m, so this m just gets brought down. Last step in this part here, 2 times negative 1 is just negative 2. But again, we are not finished, because we have like terms. I have a negative 5m, and I have a plus 16m. They need to be combined together to give me my final answer, 40m squared plus 11m minus 2. Final answer, and I'm done with example C. Example D I have finished for you here. So let me just slide this down and I'll talk you through this. So again, 3x times 2x, 3 times 2 is 6. X times x is x squared. Next, 3x times 7 is 21x. And now this is where it becomes a little bit different. So when you're doing this, again, it's very, 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 very important that you don't forget this negative sign with the 4. We're not going to do 4 times 2x and say 8x. It's a negative 4 times 2 to have a negative 8x. Okay, it's very important that you don't forget that negative. And then negative 4 times 7 is negative 28. Same thing, we have to add our middle terms because they both have an x. So 21 minus 8 gives me 13. So my final answer here, 6x squared plus 13x minus 28, and I'm finished with example D. Again, if I went through any of those too fast, make sure you go back and understand those. Example D is asking about area, so we have to do a little bit more work, but make sure that you understand that concept before you go on to example E. So you may need to rewind and watch some of those videos, or some of those examples again in this video, before you move on to example E. All right, so let's do example E here. So now, we know that the length of a rectangle is 5x plus 1. We also know that the width of this same rectangle is 2x plus 5 units long. This is something I would recommend that you do if you struggle with word problems. Go through and underline the important information. What is the area? This is what we're asked for. What is the area in square units of the rectangle? So here's my rectangle. I'm just going to draw a rectangle. I know that the length, we'll call this the length, doesn't really matter, 5x plus 1. And I know the width is 2x plus 5. Okay, so I can scroll this up because I have my information written down here. I don't need my problem. So if I'm finding area, remember area is just length times width. We're just going to multiply those. So if I'm finding the area here, I'm going to say length is 5x plus 1. And and I know my width is 2x plus 5. So I'm doing the exact same thing, I just had to set up the problem, and they weren't setting it up for me. 5x times 2x is 10x squared. 5x times 5 gives me a plus 25x. Now I'm going to distribute the 1 through, so 1 times 2x is plus 2x. I like distributing 1s because it doesn't change anything. 1 times 5 is 5. Right? 1 times anything is just itself. Let me move this down a little bit here. All right, same thing as in the last problems here. We need to combine our middle terms, 25x plus 2x. So first of all, excuse me, bring down the 10x squared. 25x plus 2x is 27x plus 5. Okay, so there are your two 1D notes. Again, multiplying a binomial by another binomial. And again, like I said yesterday, if there's anything in these problems that you are unsure about or you're confused about, please let us know. Don't let these questions just go by. Just, if you have questions on them, please let us know, because we will continue to build on these concepts. So you need to make sure that you understand these, and if you don't understand them, you need to make sure that you're asking questions. So make sure that you send me an email, send me a private comment, and I will get back to you.